Well, the last lecture for today, I'm going to talk about V4.js and make just a short version of the workshop I gave today in the morning. First of all, maybe some examples of how we can use V4.js. V4.js is basically, as I already mentioned, it's a re-implementation of V4's visual programming language in JavaScript. So we can use it to create browser-based applications or graphics and so on. So for example, here on the v4js.com page, this rendering on the top is created by V4.js, and it's WebGL graphics, which uses actually uses the graphics cards to create this 3D graphics. Most of you might have already seen this example here on the NODE website. This is also a V4.js patch, and with this renderer window spanned across the whole site. Another example, which goes beyond just creating this real-time graphics, would be something we created together with Schnelle bunte Bilder. Unfortunately, we don't have. I don't have the images here, but this is, for example, a control panel for the Katharinenturm in Magdeburg, and it's this timeline here at the bottom is the V4.js. It's output from V4.js, and we have things like we can arrange patches or presets, put it on a timeline, change the duration, change blending, change the order, and so on. And this is just to show you that we can embed V4.js into a surrounding website or web application. So all this stuff on the top is just basic web programming, PHP web application, and it is enhanced by this V4.js patch which is running and which provides this visual user interface which you wouldn't be able to create with normal HTML elements. Okay, to be able to patch V4.js, you don't need V4.x at all. All you need is a V4.js library and a Chrome web browser. For the examples, you can download them on GitHub. It's let's see, V4.js workshop. You can download these lessons from the workshop just here, download zip file. And these are just some small lectures, lessons, which are independent from each other, and with just some small examples on how to work with V4.js. First of all, we have to kind of set up a development environment. We cannot just open the file from the browser and put it into Chrome, because we would get some errors. Wrong file. We would get some errors about, well, the web browser can't load any files from the file system. You see this part at the top. This says it actually opens a file from the hard disks, and for security reasons, it's not possible. So what we have to do is we have to start Chrome with a certain flag, which is called Disable Web Security and Allow Local File Access. Okay, so this sounds scary and probably also is. So make sure that once you start Chrome with this flag and you stop working with V4.js, restart Chrome normally, because otherwise you would be very vulnerable when surfing the internet. So we have, so for that we have this batch file, which allows you to allows us to just start Chrome with the right configuration. Important here is that you close all Chrome instances before, because otherwise those flags will not be recognized. And you really have to do it with Task Manager and really have to make sure there are no Chrome processes anymore, because it's very sticky to the memory and yeah, just kill everything. Okay. About the structure of these lessons, it contains everything you need basically. There's the V4.js library itself, and there's all these lessons which refer to this library here on top of the repository. Okay, so let's start with the first lesson, which is what we have to add. You see, we get this warning message that we are now at disable web security and stuff like that. And we can, so this is a good thing that we get this now. This means that flags are recognized. So, also, I'd like to hit F12 so I get the JavaScript console, the developer console on the bottom, so I can get some response about what's going on in the browser, I get information about thrown errors and so on. Okay, so this page actually at the moment does nothing. This is the index.html. I open it with a simple text editor, and there's nothing here. And what I'm going to do now is add all the necessary code snippets to the head of the HTML file, so V4.js file gets loaded. I prepared this here. First snippet or block of code is this one. This one just loads the V4.js files that we need. Okay. The next block would be starting V4.js and initializing. Okay, let's look at that. And you really can always use these copy-paste this line of code. The only thing you have to keep track of is the location of the V4.js library. In our case now it's the parent directory and V4.js. You have to keep to maintain this here and also in this initialization call. Okay, so I'm going to save this and reload the page. And now I'm getting some status messages about all the nodes which are registered and that V4.js is ready. So the page now has V4.js loaded and is waiting for some patch file to execute. This is the last line of code we're actually touching here to include a V4 patch file, which is in our case should be called mypatch.v4p. I'm saving this and reloading, and now I see, okay, it's trying to load this patch file, but I can't access it because it doesn't exist. So we have to create it, and we create new V4.js files by just creating a new text file like this, and also using the extension mypatch. So it's really actually an empty file, and I can load this. It's okay, and nothing happens here. Okay. So we have V4.js running and the patch loaded, and good thing. Now we want to open that patch editor I demonstrated yesterday at the keynote. There are ways to do it with user interface elements, or what you always can do is append this string to the URL, which is hashtag edit slash and then the path to the V4P file we just created, my patch.v4p. I'm getting a pop-up blocker message. I say allow pop-ups here and reload. And after that, I have this empty patch loaded. Okay, and now I can start working. I can create a renderer node. There are two different renderers. The EX91, which is actually WebGL, and Canvas renderer, which does 2D canvas graphics. The Canvas renderer is good for creating clean vector graphics for user interface elements, for example, or data visualization, typography, and so on. So I'm not sure why that guy does not work here. Okay, hello. Sorry, we should continue with the other lesson. Let's prepare lesson 2. No. Like that. Yeah. Other blocker. So, okay, now it's working. As soon as I have this renderer node, it just appends a canvas element to the page. And I can set the color, for example, and so on, just as we know it from the EX9 renderer. You already user interface is pretty similar to before, but because of certain browser restrictions, we can't have the exact same behavior like before. For example, the I/O box for the color, which works pretty intuitive in before with scrolling and all the odds and stuff like that. Does not work in the browser that easy, so we created this sliders here to get over that. Also, we have these macros, which are just shortcuts, because there's no thing as a right double click, which is practical and before, but we can't do it this here. So here we have this shortcuts to create I/O boxes, for example, and so on. And this list of shortcuts is pretty easy to extend. I, for my case, often use +1 or ×2, stuff like that, and it's pre-filled with the elements. To alter these values, I right-click and I have to use the scroll wheel, the mouse wheel, to modulate the values, and use the Alt key and scroll to make it floating point numbers. Okay, so back to the graphics. With the Canvas renderer, we have certain shape nodes, which are, of course, only compatible with the Canvas renderer. For example, an arc with certain parameters, the group, pretty similar to everything we know about before already. A rectangle, you can just translate, transform it really just as you know it from before. So to style these elements, we can use canvas render state nodes, which work pretty similar to the X9 render state nodes as well. We have, for example, the fill node. To change the fill color, or stroke nodes to change stroke. With all the settings you know from vector programs like Illustrator, you can change the endings and so on. So you can just do vector graphics with the canvas renderer. There's also a file texture node for the canvas renderer, and yeah, things like that. Contrary to this, there's the EX9 renderer, which works pretty much as the EX9 renderer in classic V4. We have geometry, for example, sphere. We have shaders. Like that. And yeah, not going into detail here because really kind of works the same as in before. Some specialties are that you can't connect same graphics resource to different renderers because of certain restrictions that we haven't bypassed yet. Also, we can use the output of this renderer, this canvas renderer, as a texture for the WebGL renderer using the canvas texture node. Like so. And well, this is a bit odd for the sphere, but it's very handy to use the advantages of both systems. You can, for example, create a 3D graphics and overlay it with some vector elements you get only in this canvas environment, or text, to create some labels which you align with the 3D graphics, because at the moment there's nothing about typography in the WebGL rendering context, and you would have to do all the clean graphics stuff in canvas environment, and then somehow overlay it and merge it with the 3D environment.
So this is possible in both directions. Like you did the texture on the ball now, and can you render the texture from the WebGL renderer into the...
It's possible, but I think the node is not here at the moment. There's also the X9 texture, which at the moment works for putting it into another EX9 renderer. Technically, it's possible. The node at the moment does not exist to connect these. But yeah, basically it should work. Okay, for there's also file texture, of course, and about the file texture node, the WebGL you still have to keep the texture sizes to powers of 2, like another thing which comes from like 2006. You have to make sure that file dimensions are 64 by 128 or something like that. All those magic computer science numbers work. Otherwise, the texture won't load. This is a really common mistake I really often make, yeah, just so you know. Let's do another. Let's take a quad. And what is here is we don't get a file dialog. It's just not possible. We have to know the path to the file in our system, in our structure. And,
but you can put in online resources as well, like
yes,
full
can
URLs.
add a URL like this. But the problem is, for security reasons, WebGL does not allow you to load graphics from another server. Not sure why. In general, it's people are arguing about how safe it actually is to get something from the internet and put it directly on your graphics card. So maybe that's there's a potential security risk to get data from another server and let it execute on your graphics card. There used to be a workaround that you can load it in the canvas renderer and then pass it through, but they fixed that as well. So the only way you can do it now is you have to stream it from your web server. Somehow you have to put a PHP file on your web server, which loads the file from another server and passes it on to your VVVV.js patch. Okay. Well, pretty much the same as before for the patching stuff. We got the render states. And so on. Yeah. Okay. Any questions so far? Any more questions about graphic stuff? Yes, please.
How much of what we see is pure web standards and how much is DX?
Sorry?
How much is just pure web standards, like pure WebGL, JavaScript, and how much is kind of DX?
No, there's nothing about EX here. It's very misleading that there's any EX and DX names here. That comes from the initial goal of VVVV.js to be compatible with V4. But actually, it's all WebGL. It's pure JavaScript and WebGL. It will work with any Chrome and Firefox and Internet Explorer 10 plus. Actually, pretty good in Internet Explorer. Really fast for the WebGL stuff. But there's no plugins or anything else. It's just plain JavaScript. Okay. Well, then let's move on to the next one. Let's see. Okay. Until now, we just added graphics on the bottom of the page, but it's not the way we want to work, of course. We would like to embed it into a page and put it there where it belongs. And there might be a use case where someone creates a website and makes some place for you to put your VVVV.js graphics inside. Or you have a WordPress template, for example, where you want to put somewhere the WebGL visualization in. And we can do this. I'll show you this in this example. So if we view the source code here, we see the web developer was kind enough to place to keep this area clear and to give it a useful name for us. It gives that element here the ID header minus graphics. And we can use this reference to tell VVVV.js to put the renderer right there. So I'm going to load the editor again. add a renderer. And what I do now is change the descriptive name and give this reference to the renderer node. I do this by writing hashtag and then this header minus graphics. And now it's where it belongs, okay? The reason for the hashtag is it means take the element with the ID header graphics, okay? This is just a CSS selection, and you can just remember you can reference an element with an ID by putting the hashtag before the ID. Now we can adjust the size. For fact, I know it's 300 by 1000, and well, we're good to go to add some quads. Same as in before, we have to maintain the aspect ratio. And so on. Yeah, that's basically how you get graphics where it's supposed to be used. The same way as it's done in the VVVV.js.com website. Note about the mouse interaction here. There's the mouse node, and there are two options: system global and system window. Also borrowed from before, but this works different than before. System global means it gives you the coordinates in the whole browser window, and mouse system window means coordinates inside the renderer. This is what's going on here. Also, you can also the mouse nodes have an input called maximum touch points. You can increase that to get multi-touch support. In that case, you would get the X and Y pins spreaded for each touch point.
Are the mouse input coordinates also normalized, like in normal V4? So
they are in -1 range.
Okay, so you need to transform them as well if you have aspect ratio on the renderer.
Same as in before. Yeah. Well, it's a little complicated often because all the other coordinates in web development are in pixels, and you have somehow do the calculation if you want to match coordinates from before with coordinates from the website.
Billboard pixel precise transform?
No, actually not. You would have to do it as we have done it in before. You have to scale the view to the pixel dimensions, and then you can work with pixel coordinates like that. So it was a kind of a hard decision if which default space to use, but we stuck with the before version of this -1 to 1 range. Yes, exactly. Okay. So we're good to go for the next. This example, we see just this canvas renderer with this linear spreaded arcs, and with certain this apply style. So you can see now the range slider. But that's just for. And I can immediately use the get value. I think this is because it's zoomed here. Is this still okay for you if it's that size, or is it too small? Let's try. So, get value and put it right, no, not right here, to as value it because it's a string. And now I can use this slider like this. I can adjust the range of the slider here, and I can adjust the step size, stuff like that. Again, here the slider has just been appended to the page, and I want it actually to be where it's supposed to be. If I have a look at the source code as well, again, I see the web developer put some space which is called controls here, and this is that line, this empty box at the top, and I'm going to reference this element with the get element node. Again with this hashtag controls. And now it's inside. Of course I can now like spread these these inputs so I can get multiple. I'm just repeating this parent node here. Three times. So what we have here is the following. I'm telling the range slider that its parent node is this controls box. And if I spread this controls box 3 times, also the range slider node is evaluated 3 times. So it makes three sliders, and also the get value again has 3 outputs. So I'm just going to split those. It's too small for me. And map the values from 0 to 10 to 0 to 2 or something. And now the second slide I should modulate the other value. Well, that's basically it, a little short of time. So that's just for how to quickly create a user interface which is in this running page but can talk to stuff which is rendered in the canvas renderer. So what else do we have? Maybe we just skip that and go to the V4.js box I mentioned yesterday at Keynote, because this might be interesting for some of you. The V4.js box is a V4 module you can just put into a V4 project, and it already contains a V4.js project. It already contains the V4.js library and a template to work on. So I'm firing up V4 here. And just draw the help page. Exactly, and the moment I have this here, I can access it via the web browser. hopefully. Okay. And now I can control the before patch with the web browser. This works in both directions, and the cool thing is it also works with tablets or smartphones, kind of out of the box. And it also works with multiple devices. So if you now would take out your mobile phone and go to this, you would also have the possibility to change this patch. And also the values which go into the VVVV.js box like this are broadcasted to all the devices which are connected. Exactly. What I forgot to explain, a really important thing. Here again, I can open the patch editor. And I can change this VVVV.js patch. So let's see, yeah.
Works.
Okay, yeah. And you also see the red one moving on your phone. Okay.
Yes.
Yeah. That's great. So I can talk to individual clients. I have a list of clients here. Or I can talk to all the clients just with doing the usual spread magic here in the inputs. Yeah, we have 3 already. Okay. Great thing. So that way, and with the patch editor, you just have to use the WebSocket node on the VVVJS side. So this is VVVJS, this is V4, and the WebSocket node, you can send something which comes then out of the VVVJS box node, and the other way around. And you can then start patching your client application without having to switch to another programming language. You can stick to V4 on both sides, which is actually pretty great. The thing I forgot to mention, which is really important, is saving. How can we save that patch? It's a little odd because the browser does not have access to the hard drive by default. Can just write the file. The only thing we can do is hit Control-S and download it. And we have to make sure that we put it then into the right directory and really overwrite the actual file which has been loaded. So you kind of save, circumvent the browser and save going through another channel. And this is kind of clumsy, and each time you save, you have to keep you have to be really careful to overwrite the right file. So if you have a lot of sub patches, for example, this is something which can cause you a lot of pain if you overwrite the wrong sub patch, because you also have to really save each sub patch, and you have to select the right one to do so. Okay. Cool. Basically, that's it. Yeah. Any questions?
How good is it with the performance, with the connection between the V4 patch and the WebGL node?
That depends on the network. I've not tested it over the internet. Mm-hmm. Not sure,
but in a local network, sending real-time data like audio analysis from somewhere.
Yeah, those values are then queued, and you get some trading effect. So you move if you keep moving and moving, the movement is queued and it's executed late. There's, of course, some latency, but for time discrete data, punctual data, it's working. All right. Yes, please.
Is it possible to change the size of the renderer depending on the window size? So if I resize the window, the renderer also changes its size?
Yeah. There's, this is what's actually happening here. Let's have a look at it. There's a screen info node, which gives you information about the window size, and then you can adjust the back buffer width and height pins accordingly. Okay. All right. Thank you.